Our Earth spins on its axis as it revolves around the sun. These two things give us day and night and also the seasons we see in a year. Our Earth also has an atmosphere. This atmosphere keeps all the necessary gases in the Earth in order for all of us to exist and survive. The main gas in the atmosphere is called nitrogen, and nitrogen is one of the elements that are necessary for us to exist and survive. What's up, everyone? It's Mr. Ramble coming at you with more science. Today we have two things on schedule. First, we'll review how organisms access the resources they need in order to exist and survive. These resources, as we already know, come from our matter cycles. We'll specifically go over the first two matter cycles we went over, the water cycle and the carbon cycle, through reviewing the quiz questions we took last week. Second, we'll begin learning about the nitrogen cycle by identifying why nitrogen is important in the first place. First, let's make our way to the Do Now, which is attached to today's morning announcements. On your Do Now, you'll notice it's titled How Carbon Moves on Earth. Go ahead, write your name in the left column, and in the other column, write down an example of how carbon moves on the Earth. Remember, there are 4 different spheres of our Earth in which carbon can move in through. The biosphere, hydrosphere, geosphere, also known as the lithosphere, and the atmosphere. Take some time to review your peers' comments and also the comments I make on your peers' responses. For our first goal today, let's review the quiz questions we missed the most last week. As we know from a previous lesson, our universe began or showed up when this thing, a singularity called the Big Bang, appeared out of nowhere. I believe this was out of confusion, and I talked to a couple of you, but the Big Bang did not create, let me say that again, the Big Bang did not create anything. Here in your simulation that's attached to the morning announcements, we see that the Big Bang formed, the word is formed here, atoms and elements from hydrogen, helium to our carbon and nitrogen. It formed all of those. But given our laws of conservation of matter and energy, which state that matter and energy cannot be created or destroyed, this means, yes, you guessed it, that the Big Bang did not create anything. It simply transformed and transferred different matter and energy into the universe we know today. Now, these same two scientific theories or laws will be applied to the carbon cycle. This question highlighted is the other question that we missed the most in last week's quiz. And once we apply the concept of the law of conservation of energy and matter, we can see that the carbon cycle can't actually ever end. Because first of all, it is a cycle. It needs to cycle in order to provide us the things we need to continue to survive. Now, don't get me wrong, the carbon cycle can stop, and it can stop one of 2 ways. The first way is if the sun stopped shining and if it was night all along. And that has to deal with the chemical equations of photosynthesis, which stands or incorporates the element of carbon in it. Autotrophs using photosynthesis take in carbon dioxide and water in order to create that stored energy. Without the sun, it won't be able to do that. So that carbon would just be sitting there and not being formed into that stored energy. Thus, the carbon cycle sort of stops. We won't talk about that second way, but we need to know that first way. And lastly, autotrophs aren't the only ones that can actually transfer carbon. Heterotrophs can as well. Let's move on to today's second goal, which is identifying why carbon, or nitrogen actually, is important in our lives. On the screen, you see the chemical constructions of our DNA, which are the things that make up our genes. All the ends that you see in these chemical constructions, so how our DNA is made up, what elements they are, all these ends are actually nitrogen. Nitrogen is the main component that makes up our DNA. So without nitrogen, we actually would not exist. Nitrogen is also a big part of our atmosphere, taking up most of its space. But the thing we're going to learn today is that we actually can't get nitrogen directly from the air. We actually need things that convert nitrogen into things that we can actually use to sustain our bodies. So one, we wouldn't be able to live without nitrogen because it is part of our DNA. We need to continually replenish that nitrogen or else we wouldn't be alive. We actually can't get nitrogen by ourselves. Heterotrophs need something else in order for nitrogen to be converted into a usable form. So we rely on autotrophs, and autotrophs rely on microbacteria in the soil to convert atmospheric nitrogen into usable nitrogen. And they do this in a process called nitrogen fixation, which means that they fix atmospheric nitrogen. These microorganisms fix atmospheric nitrogen into a usable nitrogen that autotrophs can use and then therefore heterotrophs can use, because we as heterotrophs consume autotrophs for both our carbon and, now that we've learned, our nitrogen as well. Go ahead at this time, complete your exit ticket. And once you're complete, submit that before the end of the day at 3:30. Lastly, in the announcements, you'll find this as homework due by the end of the day at 11:59 p.m. This reading is about the nitrogen cycle, and we talked about the first step. We can't use nitrogen. We need microorganisms in order to transform or convert atmospheric nitrogen into a usable nitrogen. That's the first step to the cycle, and this step is called nitrogen fixation. For homework, go ahead and read this document 2 pages and answer the 3 reflection questions at the end and submit by the due date. If you have any more questions or any curiosities about the nitrogen cycle or anything we've talked about prior, let me know. Have a great day.